Hi everybody. Today I'm going to talk about the CK12 lesson 1.3, and there is some reading you can do on that embedded in our module, but I wanted to put this video there to help clear up some of these nasty math terms and make you not so concerned about them. Hopefully this will stick in your head and make it easier for you to remember. So I want you to imagine these real numbers. I'll circle this here. These real numbers are all the numbers that you've ever known, right? Some of those numbers might be the number 2. We've known that for a long time, or -7, or 105, or 1/2. Those are all numbers that we're familiar with. And what we're going to do is we're going to take all those numbers and we're going to sort them into some categories. So let's get started. For the first one, I'm going to start over here at this kind of green bubble that's off by itself, and those are called irrational numbers. And I'm going to go real quick here. It takes a second for it to open. I'm going to open my math program because these are kind of quirky numbers and I need some help typing them in a Google Doc. So this program lets me do some of that. Now, these irrational numbers are numbers that never end and never repeat. And I think the most famous one of those is this guy, pi, right? But there's other numbers, if you have a calculator, you might want to try this, other numbers that also, if you type in your calculator, they look very quirky. They just fill up the whole calculator bank. And that's because they never end. And more fascinating, just like pi, they never have a pattern. They never repeat themselves. It's very strange. A square root of 5 is another irrational number. Put these in your calculator if you want and see that they really do seem to fill up that whole bank and go on forever. Square root of 2 is another one. Okay, I'm going to put that in there, and if you're taking notes, it's a good idea to write some of these down where it says irrational. And the other thing you should most definitely write down is that these are non-repeating. I think I should put a hyphen in there. Non-repeating and non-terminating. Oh my goodness, I know all these big words. But what this basically means is that they do not repeat, don't repeat, and they never end. Crazy. Okay, now let's go with some of the numbers that are a little more predictable. Those are the rational numbers. And let's start in here at this inner orangey colored bubble, the natural numbers. They're also called the counting numbers. If you have a younger sibling and you ask them to count for you, they'll probably say 1, 2, 3, and go on for as long as they can count. Those are the natural numbers or the counting numbers. The whole numbers, I've put the orange bubble inside the blue bubble, that's for whole numbers, because all the natural numbers are also whole numbers. The difference is that the whole numbers invited another number to join the club, and that number is 0. And then, of course, 1, 2, 3, and all those numbers that are natural are also in the whole number group. The integers include all the whole numbers and natural numbers, 0, 1, 2, 3, but they invited some different numbers to the club. They invited the negative numbers, -2, -1, 0, and so on, and all the positive numbers. So any negative number, or whole number, positive number, 0, those are all in the integers. Now, what we've been leaving off is everybody's favorite, these rational numbers. Rational numbers are fractions and decimals. These are things that are parts of numbers, everybody's favorite, right? And some examples of those would be like 1/3. If you put that in your calculator, it does go on forever, but it repeats. It's 0.333333, and that's why it's not irrational. It's very predictable. If you put 1/2 in your calculator, you'll notice that that just gives you 0.5. -3/5 is also a fraction that can go in your calculator and it will end. Or sometimes you're just given a decimal, 0.67. That's a rational number as well. Rational numbers include all these fractions and decimals plus all the whole numbers and natural numbers. And that's all I have for you today. Thank you.